So, welcome to lecture 12 part 3 Introduction to Logic Families. So, in this slide we will discuss about diode transistor logic or DTL. So, in the previous slide we discussed about RTL. So, it has couple of disadvantages like RTL has less noise immunity, the fan out is less, also power dissipation is very high for RTL. So to overcome all of this effect, we use the DTL. So in DTL, we can overcome all of them. So this is a typical circuit representation of diode transistor logic or DTL, and we can implement the basic NOR gate using DTL. This is basically two input NOR gates. So as it is a diode transistor logic, that's why we have diode here and transistor here. So instead of two diode, we can input n number of diodes as well. So in that case, here your this section will be increased. So there will be n number of diode. So you can see here in your diode. So this is your positive anode terminal. This is cathode terminal. So anode is connected to VCC. So that means so this is actually in reverse condition because this is connected to VCC. So reverse bias condition. So if we give a 0 here, then the diode will turn on, so it will be shorted. Like if you give 1, then this diode will not turn on, or it will be open circuited. So if you give A equals 0, B equals 0, so then it will be shorted. The 0 will come here, and it will and in this terminal, so this 0 also come to that transistor, and the transistor will be off because we are giving the 0, so this will be open circuited. So if this is open circuited, then our V0 that will be connected to VCC. So for 0 0, then we are getting high, or our output is high. So in the previous slide we discussed about 0 0 condition. So let me use the laser pointer. So for 0 0, like for 0 0, so you are getting 0 here. So this transistor will be off and it will be open circuited. So we are getting V0 is connected to VCC, that's why we are getting high. So for 0 1 or 1 0, so say like for 1 0, so this is 1, this is 0. So this is 1 means this will be off. So that means open circuit is 0 means this will be on. This is shorted. So this 0 comes here. So again, this will be off. This will be open circuited. So we will be getting V0 equals high. So for 0 and 1 0, just look at the circuit here. So this part will be open circuited, right? So you're getting V0 is connected to VCC. For first one, V0 is connected to VCC. That's why all these three cases is high. Just look at the last condition. This is 1 1. So if this is on, this is on, that means this will be not conducting. This will be open circuited. That is not conducting, open circuited. So that means then only this one is connected to ground. So current will be passed through VCC to ground, as these are open circuited. So then we are getting B0 is connected to ground. That means we are getting output equals 0. So if you look at the output carefully, so it says when both of the input is 1, the output is 0, otherwise output is high, which is a expected output of NAND gate. So that's why in detail we can implement the detailed logic in implementing universal NAND gates. So if we can implement one of the universal gate, we can implement the other gate as well. So in detail noise, fan out and dissipation improves, but the circuit is slow. Therefore, we use TTL for faster operation. So in next couple of slides, we'll discuss about the TTL and we'll discuss about how we can improve the speed in the TTL logic. So here is another assignment for you. So the assignment is about register transistor logic RTL. So you need to implement uh, the two input NAND gate using the RTL logic. So transistor logic or TTL. To overcome the speed issue in DTL, we use TTL. So this is the schematic diagram of TTL or transistor logic here. So this is our T1 transistor, T2 transistor, T3 transistor. So this is also called multi input transistor as well. This is our VCC, this is our V0, the output, and they are connected to ground. So this is actually common, this is actually emitter and base transistor, these two, and this is called collector and emitter transistor. So here you have three input. So if you are asked for multi-input transistor, you can plug in here n number of input as well. Okay, so when any of the input emitters is 0, when any of them is 0, it will provide 0 to T2 and for T3 both. If any of them is 0, so it will provide 0 here and 0 here, which means the T2 and T3 transistor will be in cutoff mode. So cutoff means they will be open circuited. So due to open circuited, so T2 and T3 will be off. When all of the input emitter is high, it will provide 1 to T2 and T3. So if all of them are high, then it will provide 1 to T2 and 1 to T3, which means transistor T2 and T3, both of them will be saturation mode. In saturation mode, they will be shorted. So that means this one will be shorted, this one will be shorted. That means T2 and T3 will be on. Okay, so based on that, if we try to draw the truth table, so we consider three input 1, 2, 3 as A, B, and C. We have the output and V0. So we know if A, B, C both of them are 0. So if all of them are 0 actually, so all of the so it says when any of the input emitter is 0, that means if any or all of them are 0, so then what will happen? We need to determine. So we know if any of the input is 0, it will be providing 0 here, it will be providing 0 here, which means it will be in cutoff mode and it will be open circuited. So if this is open, this is open, so that means there is no connection for V0 to ground, right? So this is open, this is open. That means our V0 is directly connected to VCC. So we are getting output as high. But if so we consider all zero, then what will happen? I have to determine. But before going to that, so we can write like 0 0 0 is high, 0 0 1 or 0 1 0 up to 1 1 0, it will be high, because we know if any of the input or all of them is high, then T2 and T3 will be in cutoff mode. That means T2 and T2 will be open circuited and that will be off. So then we are getting output V0, which will be connected to VCC high. So we will be getting high. Now consider if all of them are high, A, B and C. If A, B and C are high, then T2 and T3, so both will get 1. So that will be in saturated mode, which means this one is short circuited, this one is short circuited. If T2 is short circuited, that means V0 is connected to ground, throat is shorted, or throat is shorted. So then V0 is connected to ground, that means we are getting output at 0. So if all of them are 1, we are getting 0. So which means this is for, like, if all of the input is 1, then we are getting 0, otherwise 1. So this is the representation of NAND gate. So transistor logic, through this transistor logic, we are implementing the NAND functionality. So TTL used in small to medium scale integration. However, I2L or PMOS or NMOS is used in large scale integration. So there is one assignment for you. So we need to implement TT and NAND gate with totem pole output. So the totem pole circuit is very important. So you need to implement TTM NAND gate with totem pole output. So this is one of your assignments.